Hi friends, welcome to follow up. Let's have a look at a newly appeared problem. Problem 2838. Maximum coins. Maximize. Hi friends, welcome to follow up. Let's have a look at problem 2838. Maximum coins heroes can collect. In this video, we're going to explain a solution based on the strategy sort plus partial sum plus binary search. So here in this problem, we're not going to read through all the problem statement, but we want to point out here one note. So the health of a hero does not get reduced after defeating a monster. So multi-heroes can defeat a monster, but each monster can be defeated by a given hero only once. So these two notes are actually very important, especially the first one. Actually, the first note greatly reduces the difficulty level of the problem. So here we have three examples. The third one is very special because the heroes have power 4 and the monsters had a minimal power 5, so no heroes can defeat the monsters, so we output 0, 0. So similarly you can look at this one. So example 2, so we can beat all these monsters. So if you compute the coins sum, so we're going to have 23rd, right? 23. So similarly, you can look at example 1. So for example, hero 1 can beat the monsters with power 1, 1, and the hero 4 can beat monsters with power 1, 1, 2, 3, and monsters hero with power 2 can beat monsters 1, 1, 2, right? So for this problem, actually the logic is very simple. So here what we actually should focus on is time complexity. So because here the heroes can be as long as 10 to the power 5, and monsters can also arrive at this length, right? So we cannot just do for loops. So here we are going to use partial sum. Actually here the partial sum comes into play due to the fact that so if a hero can defeat a monster, so all the monsters with smaller powers can also be defeated. So basically this is the way, this is where the partial sum comes. And also we want to use binary search, so we can find an index corresponding to the power of the hero, and then any less power monsters can be defeated. So that's the main consideration. So now let's look at the coding part, and then we can digest the logic together. So first, let's get the number of monsters. So this is just for convenience. So now let's maybe also m, right? Let's write it simultaneously. M and n will be the length of heroes. And then what we want to do, first we want to do a sort powers with coins. So we can sort the monsters according to their powers, and then we can arrange the coins accordingly, right? So this way we can zip or put together the monsters and coins so that we have strict correspondence. So we can use zip function, so monsters and the coins, right? So the key actually will be the natural key for the monsters from small to large, but here to make the logic clear to emphasize the idea, let's sort according to the first key first. Then after this sort, so we can get the monster powers and we can get the monster the corresponding coins, right? Let's retrieve this information. So let's see monster powers. It's going to be x naught for x in powers with coins. So this will get the corresponding monster powers, and then we can get the corresponding monster coins. So this, let's copy this part, and then we retrieve the second component, so that is x1. So we want to, because if we can beat one monster, then all the monsters to the left can also be defeated, and then we can get the corresponding coins up to that monster. So we can actually here use partial sum or prefix sum. So we can do it directly in this this monster coins list. Let's do this for I in range. So notice that these monsters and coins have length m. So we are going to start from 1 and ending at index m-1. So here the first one will keep fixed, and then the other ones is actually the following. Coins, the current one will be incremented by the previous one. If you look at it as a whole, it's going to give us the corresponding prefix sum or partial sums. So with that done, basically we can compute the result. So here let's get our result. Let's initialize this like this, because the result will be of length n, right? Then for each index we want to fix the result. Then what we want to do, we want to get the IDX, right? So bisect. So we use bisect left, right? Bisect bisect left, right. Let's use right. So then we have monster powers, and then the power of the ice heroes, right? So here this IDX will be the corresponding insertion place for this hero. So here the IDX satisfies the following position. So every index left to the IDX will be less than or equal to the power of hero's I. So this is what we want. Actually, if they have the same power, the hero can defeat the monster. So then let's do if IDX equals 0. It means that the hero can beat nothing, right? In this case, the result I is going to be 0, or we just leave it as it is. So let's just leave it that. Then if IDX is greater than 0, right? It's possible that this IDX is n. It means this hero can beat all the monsters. But anyway, so result I so will be monster, so coins. So we want to compute sum up to the index before this IDX, right? So we are going to compute IDX minus 1. So this is important. So that's why, even if IDX equals m, so this is still okay, because the monster coins we are retrieving is IDX minus 1. If IDX equals m, so this will be n minus 1, still the largest one, in other words, the total. So with that done, basically we can return the result stage. So before we make any comments, let's first do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So now let's make an extension so we can practice more. So here the note is that the health of the hero does not get reduced after defeating a monster. So how to solve this problem? If we do not assume the above observation or hypothesis. So in other words, so the health of a hero would get reduced after defeating a monster by the amount of the monster's power, and then we want to compute for each hero what's the corresponding score or a number of coins the hero can get. So that's actually another problem or variant. So if you are interested, you can have a try, and also if you have a solution or some suggestions, you can post in the comments. So with that said, basically we are done about this video. Thank you.